Hey everyone, and welcome back. Ready to dive into something new today?
Always. What are we tackling in this deep dive?
Well, I'll be honest, it might sound a little dry at first glance. Land classification.
Land classification. Okay, I see where you're going with the dry comment.
Right, but trust me on this, it's way more interesting and honestly way more important than most people realize.
I'm intrigued. What makes it so important?
It affects all of us, whether we realize it or not, even if we don't think about it every day.
It's one of those things running in the background of our lives, isn't it? We don't always see it, but it shapes so much of what we experience.
Exactly. And to help us break it all down, we're tapping into the work being done by Pharmanaut.
Farminaut, I've heard of them. They're doing some seriously cool stuff with technology and land classification.
They really are. They're using some cutting-edge tech to bring land classification into the 21st century and beyond, really.
They're definitely at the forefront of this field. And what they're doing is about way more than just drawing lines on a map.
Right. It's about using data to make smarter decisions about how we use and manage the land, which is a pretty big deal.
Huge. Okay, so before we get into the how, let's step back for a second. Why should we even care about how land gets classified? What's the big deal?
Well, imagine just walking through a park, just a beautiful, peaceful city park. That park probably exists because someone, somewhere, classified that land as being good for recreation.
Instead of, say, a good spot for an apartment building or a parking lot.
Exactly. They might have determined it wasn't the best for building houses or for farming. And that decision, that very basic land classification decision, is what led to the park.
Wow, I never thought of it like that.
Most people don't. But just goes to show this isn't just about maps and data points. It's about making decisions that directly affect our everyday lives.
And those decisions then have ripple effects, don't they? On everything from how cities are planned and how we manage resources to environmental protection and even the economy.
Absolutely. And I was reading through the Farmanaut material, and they mentioned a ton of different ways it's applied. Everything from helping farmers figure out what to plant to guiding those bigger policy decisions about how to protect endangered species.
Right, and it's not always those big picture things either. Let's say you're worried about wildfires. Knowing how the land is classified, what's forested, what's dry brush, what's near neighborhoods, that can be really important for predicting how a fire might spread, for example.
And then even for taking steps to prevent them, or at least mitigate that risk.
Exactly.
Okay, now you're making me nervous.
Yeah.
But I get your point. So how do we even begin to classify something as huge and complex as, land? It's not like we could just ask the trees and mountains to neatly categorize themselves.
Right. And even if they could, I'm not sure we'd understand the answer. But you're right, it's a massive undertaking classifying land. But thankfully, we've got some pretty incredible tools these days. Satellite imagery, for one. It can tell us a surprising amount about what's happening on the Earth's surface.
Wait, so we're talking about actual satellites? Like the ones that help us get around with our phones, taking pictures and telling us what's what down here?
You got it.
That's wild.
It's more than just snapping pics, though. These satellites use a bunch of different technologies to analyze the light that's reflected off the Earth.
Okay, so by analyzing light, we can know what's happening beneath the surface. How does that work? Tell me more about this.
It really is like we're cracking a code because different surfaces, different materials, they all reflect light in their own way, right?
Makes sense.
A forest is going to look totally different from a desert, and a desert's going to look different from a city.
Right. But how do we get from those light patterns, to actually being able to say, okay, this is definitely a forest, this one's a farm, and so on?
Well, that's where the really cool stuff comes in. We use these things called classification algorithms, basically computer programs, and they can analyze all those patterns of reflected light. And then what's really neat is they match them to land cover types that we already know about.
So it's like having a super detective, but instead of looking for clues at a crime scene, they're looking at light.
Exactly. They're sifting through all that data and saying, okay, I've seen this before. This pattern means it's got to be a forest.
So like those facial recognition programs, but instead of recognizing a face, it's recognizing a forest or a desert.
You got it. And those facial recognition programs, they're getting more and more sophisticated every day, right?
It's a little scary how good they're getting.
Tell me about it. But the good news is our land classification algorithms, they're getting better too. More sophisticated all the time.
So we're getting more detailed and accurate.
That's the goal. They're able to take into account way more data now than they ever could before.
That's really incredible.
Yeah.
But I do have to ask, what about the times when it's just not enough to see what a satellite sees from space.
Oh, for sure. Satellite imagery is amazing, don't get me wrong, but it's not a magic solution. It has its limitations.
Right.
Sometimes we need to double check what we're seeing up there from way up high with good old-fashioned ground truthing.
Ground truthing, is that what it sounds like? Like actually sending people out into the field to see what's up?
You know it. You got it. Might seem a little, I don't know, old school compared to all the satellites and algorithms.
A little less Star Wars, really.
A little. But it's still absolutely essential.
So we've got these high-tech satellites, but we still need boots on the ground.
100%. We need to be sure what those images are suggesting is actually right. And sometimes those ground truthing missions, they can uncover some pretty interesting things we'd never see from space.
Like what?
Well, it could be something like a super rare plant species that's only growing in this one tiny spot, or even signs that people are changing the environment in ways that we didn't realize.
It's like having a team of detectives, but for the planet. Gathering evidence, making sure we've got the full picture.
Exactly. And speaking of getting the full picture, let's not forget about the past.
What do you mean?
Well, think about it. We've got aerial photographs that go back decades.
We do? Wow, okay.
We do.
Yeah.
And when we compare those to what we're seeing now, it's a game changer. We call it temporal analysis.
Okay, hold on. Temporal analysis, that sounds pretty intense.
I know, kind of a mouthful, right? But basically, imagine being able to rewind the planet, like see how land has changed over time.
Now that is cool.
It is. We can see where forests used to be, how cities have grown, how farming practices have changed things, all of it.
Wow. It's like having a time machine for the Earth.
Exactly. And think about the insights we can gain from that, right? That helps us see how we're impacting the environment. We can literally see deforestation, how urbanization is affecting things, even how some agricultural practices have damaged the soil.
So it's not just about knowing what's there now, it's about understanding how we got here so we can make better choices moving forward.
100%. So now that we've got a good handle on the how and the why, you ready to jump into the actual categories of land?
Let's do it. We've got all the tools laid out. Let's see what we're actually classifying. What are the main types of land we're talking about here?
Well, think of it like, I don't know, like organizing a super messy drawer.
Okay, I can visualize that. Whose house are we at? Because my junk drawer is a disaster.
Oh, same here. But except instead of a drawer, it's the whole planet. And just like you wouldn't throw your socks, your shirts, and your kitchen stuff all in one big pile, we've got to categorize the land, right? Based on what it is and how we use it.
So no more cramming everything into the land drawer equivalent of that one junk drawer we all have.
Nope. Got to bring some order to the chaos. It's about making sense of this huge, crazy, diverse thing we call land. So let's start with one of the most important, agricultural land.
Okay, so that's the land where we grow our food, right?
Yeah.
But I'm guessing it's not as simple as just saying, yep, that's farmland, and calling it a day.
You're way ahead of me. You're absolutely right. There are actually a lot of nuances even within agricultural land. We've got cropland, for example, where all those fruits and veggies and grains are grown. And then there's pasture land, which is for grazing livestock.
Makes sense.
And we can't forget orchards, those beautiful places full of fruit trees, even land that's left fallow for a season to let the soil recover. That counts as agricultural land, too.
Wow. So even within that one category, there's a ton of diversity.
Yeah.
And I'm guessing each of those types of farmland requires its own special way of being taken care of.
You're exactly right. It's not just about drawing lines on a map and saying done.
Yeah.
It's about making sure that we're using the right tools, the right techniques for that specific type of land. We're not managing a cornfield the same way we'd manage, say, a vineyard.
Totally.
And that's what classification helps us do, make those differences crystal clear.
It's like each piece of land has its own little care plan.
I like that. Okay, so we've got our farmlands figured out. Now let's move on to another category that's absolutely crucial for the planet's health: forest land.
Okay, forests.
From the huge boreal forests up north to those lush rainforests, they're essential to, well, pretty much everything.
And of course, there are all kinds of forests, too. I was reading the Farminaut stuff, and I think they mentioned something about how you have to classify for dense forests versus open forests. What's the difference?
Good catch. You're right, we can't just lump all forests together. A dense forest, just like its name suggests, it has this really tightly packed canopy, tons of trees, not much light getting through to the ground, and that creates this whole other environment down below.
Right, right.
But open forests, they've got a bit more space between the trees, more sunlight's able to reach the ground, so it's a totally different ecosystem.
So even something like how much sunlight gets through the trees, that can determine what kinds of plants and animals can survive there.
Exactly. It's all connected. And that's exactly why we differentiate between these forest types. They're each home to their own web of life, and they need to be managed in specific ways to make sure that they stay healthy.
It's like each forest has its own personality, its own needs.
I love that. Okay, ready to switch gears.
Sure.
Let's move away from the natural world for a minute and head into a landscape that's very much shaped by us humans, urban land.
So cities, towns, suburbs, all that. Honestly, it feels kind of strange thinking of a bustling city as land.
I know, right? It's kind of funny to think about it that way, but when we're talking about land classification, a city really is like its own ecosystem, just one that we've modified quite a bit. Residential areas, shopping centers, industrial zones, roads, even those tiny little parks we try to squeeze in.
It's a good reminder that even the most urban places, we're still part of nature, even if we don't always think about it.
Exactly. And our cities are only getting bigger and more complex, so how we classify and manage urban land, that's becoming more and more important if we want to create communities that are livable and sustainable.
It's like trying to find the balance, isn't it? Between the built world and nature.
All the time. Speaking of nature, though, what about the parts of the planet that are covered in water?
Good point.
We can't just lump all that together as water, can we?
No way, there's a lot of water on this planet.
There is. So we've got rivers and streams, lakes and ponds, and then there are the coasts where land and sea collide. We even classify wetlands, those spots where the water covers the soil for at least part of the year.
Wetlands are so important though, right? Even if they're not the most glamorous places.
100%. They do so much, filtering pollutants, preventing floods. They're home to a huge range of species. So important. So yeah, water is way too broad of a category. We've got to break it down.
Makes sense. So we've got agricultural land, we've got forest land, we've covered all those urban areas, and the water, what's left?
We saved well, I guess you could say we saved the most seemingly barren for last.
Barren land, okay.
Yeah, so this is the land that might seem, I don't know, kind of empty, desolate even at first glance, but it's important.
Like, what kinds of places are we talking about? Because barren makes me think of like a wasteland.
You could think of deserts, definitely, places with not much rain, not much vegetation, or rocky areas where only the toughest plants can make it, even those big shifting sand dunes. It's easy to think of those places as lifeless, not important.
But they're not lifeless, are they?
Not at all. They might not have the same kind of biodiversity as a rainforest, for instance, but they're full of incredible plants and animals that have figured out how to thrive in those conditions.
It's a good reminder that life finds a way. So even the places that seem the toughest, there's still a delicate balance going on.
Exactly. And knowing how to classify those barren lands properly, that's how we can start to understand how to manage them, how to protect them, even if they don't have the same obvious beauty as a forest.
Because they are beautiful in their own way. Okay, so we've covered a lot of ground here. We've got our farms, our forests, our cities, our wetlands, our deserts. It's like looking at this incredibly detailed, colorful map of the entire planet.
It really is. But remember, those classifications, they're not just for making pretty maps. They have a real impact on how we manage our resources, how we protect those diverse ecosystems, and how we plan for what's coming next.
And that's where a company like Pharmanaut comes in. They're taking all this knowledge, all this data, and turning it into practical tools, things we can actually use.
They really are. What I find so exciting about them is how they blend that cutting-edge technology with this deep understanding of the land itself. It's a powerful combination.
So what does that look like in the real world, though? Give me an example. How is Pharmanaut's work actually making a difference?
Let's say you're a farmer, and you've noticed that part of your field just hasn't been producing as much as it used to. Now, you could just shrug it off as bad luck. Or you could use Pharmanaut's technology to take a closer look. They can analyze satellite images, soil data, even weather patterns, and pinpoint what's going on.
So instead of just seeing a field, this farmer is suddenly seeing this, this incredibly detailed breakdown of everything that's happening.
That's a great way to put it. What nutrients are in the soil, where irrigation might be a problem, the works.
It's like having a whole team of agricultural experts, but it's all right there on your phone.
You got it. And that level of precision, it's not just good for the farmer, it's good for the environment too, because by using resources more efficiently, we reduce waste, which helps everyone.
It's that win-win we love to see. The article also touched on how this kind of technology can be used in disaster management too, which seems like a totally different thing.
It is, but the basic idea is the same. Use the best information we have, keep it updated to make the best decisions. So let's say there's a huge wildfire. By knowing exactly what types of land are in its path, forest, grassland, residential areas, firefighters can get a better sense of how it's going to spread.
And prioritize where they send resources.
Exactly.
Wow, this has been eye-opening. We really do take land for granted.
It's true. And with things like climate change and a growing population, knowing how to classify and manage land responsibly, well, it's only going to become more important.
So what's next? What's on the horizon for the world of land classification?
Oh, there are some incredible advancements coming down the pipeline. Imagine being able to see not just, oh, that's a forest, but the health of each individual tree.
Whoa, hold on.
I know, right?
Right.
But we're talking about being able to see the moisture levels in the leaves, even signs of disease from space. That's the future of hyperspectral imaging.
So we're talking about diagnosing a tree from space.
We are. And then there's AI, those algorithms we were talking about. As they evolve, they'll be able to analyze even more data, spot patterns we wouldn't even know to look for.
It's like we're entering a whole new era of understanding our planet.
We are, and we're just getting started.
I'm excited to see where it all goes. But in the meantime, I think we've all gained a new appreciation for the importance of land classification. It's about so much more than just data points on a map. It's about understanding our planet so we can make better choices.
Beautifully said. And if anyone out there wants to learn more, definitely check out Pharmanaut's website. They've got tons of information and even some really cool interactive tools so you can play around with land classification data from all over the world.
We'll make sure to link that in the show notes. And on that note, we're wrapping up this deep dive into the world of land classification.
It was a fun one.
It really was. Until next time, keep those minds curious, and we'll see you on the next deep dive.
Wow, so much more to it than meets the eye. Right. Who knew there was so much to learn about? Well, just dirt and rocks and water. Right. But you made a good point earlier. Even those seemingly barren landscapes, they're teeming with life.
Absolutely. Okay, so we've done a pretty good job of covering the different land classifications, haven't we? It's like, I can picture this giant color-coded map of the planet now.
It is a bit like that, but it's not just about, making a pretty picture.
Right.
These classifications actually matter
They do.
because they change how we manage resources, how we protect biodiversity, how we plan for the future, all of it.
And this is really where a company like Pharmanaut is doing some really cool stuff, don't you think? Taking all this knowledge, all this data, and turning it into something useful.
Absolutely. That's what's so fascinating to me about them. They're combining this high-tech approach with a really deep understanding of, the land itself. And it's that combination that lets them build these really incredible tools.
Could you give me an example? How is it actually playing out in the real world?
Sure. Let's say you're a farmer, and maybe you've been noticing that a certain area in your fields just isn't producing as much as it used to. Now, you could just assume it's bad luck, right?
Right.
Or you could use Pharmanaut's technology to get a better look. They can analyze images from satellites, soil data, even weather patterns to try to figure out what's going on.
Wow, so instead of just seeing a field, they're seeing like this incredibly detailed breakdown of everything that's happening at a granular level.
Exactly. They can see what nutrients are in the soil, where irrigation might be a problem, all of it.
It's like having a team of experts, but it's all right there in your hand.
That's a great way to put it. And what's really cool is that this kind of approach, it's not just good for the farmer, but it's good for the environment too.
How so?
Well, because when we can use resources more efficiently, we're not wasting stuff. And that helps everyone.
That's the win-win we love. I also read that Pharmanaut is applying this in disaster management, which seems like a completely different area.
It is a very different area, but the same principles apply, right? You use the best data you have to make the smartest decisions, especially in those critical situations. So let's say there's a wildfire.
Okay.
By knowing exactly what kind of land is in the fire's path, where are the forests, where's the grassland, are there residential areas nearby, that helps firefighters get a better sense of how that fire is going to behave.
And focus their resources in the right places.
Exactly.
This has been a fascinating conversation. It really makes you realize how much we take the ground beneath our feet for granted.
We really do. And with climate change and the global population growing, it's more important than ever to understand how to classify and manage land responsibly, for our sake and for the planet's.
So any last thoughts for our listeners? What's next for this field? What should we be paying attention to?
Oh, there's a lot to be excited about. But I think the biggest thing to keep an eye on is how these technologies continue to evolve.
Hmm.
It's incredible to think about what's possible even just a few years down the road.
I'm ready for it. Well, thanks so much for taking the time to chat with us today. I think it's safe to say we've all learned a thing or two about land classification.
It's been my pleasure.
And for all of you listening, thanks for joining us on this deep dive. We'll catch you next time.